Hello guys, welcome back to ESci 116 and Differential Equations, and today I will be solving practice problems using that are involving in homogeneous differential equations. So here for number 1, we have y squared dx plus xy plus x squared times dy is equals to 0, and x is equals to 0 and y is equals to 0. X is equals to 2 and y is equals to 1. So to answer this, so let us write the equation again. That's y squared dx plus the quantity of xy plus x squared times dy is equals to 0. Now we need to rearrange the equation so that we can get dy over dx. So we can do that by putting y squared dx to the right side. So we have left is xy plus x squared dy is equals to negative y squared dx, and then we can divide both sides by dx as well as divide both sides by xy plus x squared. Now we have dy over dx is equals to negative y squared all over xy plus x squared. Okay, so remember guys how to solve homogeneous differential equations. We are going to substitute our y over x with a variable v. So that's v is equals to y over x, then our y is equals to vx, and our dy over dx is equals to v plus x dv over dx. If you guys don't know where this come from, please I urge you to watch our instructional video once more. So we have dy over dx is equals to v plus x dv over dx because of the chain rule. Okay, so we're gonna use those formulas to solve this problem. So we just need to plug in our values here. So our dy over dx becomes v plus x dv over dx is equals to negative y over x squared all over x times vx. Oh, sorry. This is not y over x. This is vx because we are substituting the value of y. Now moving on, that's plus x squared. Okay. So we have v plus x dv over dx equals to negative v squared x squared, distributing the square. Then we have vx squared plus x squared. Now we can simplify this by factoring out our x squared. So that's v plus x dv over dx is equals to x squared times negative v squared all over x squared times the quantity of v plus 1. Then we can cancel out x squared because it exists both in the numerator and denominator, and it equates to 1. So now we have x dv over dx. We're gonna move our v to the right side. That's negative v squared all over v plus 1 minus v. Next, that's x dv over dx is equals to v plus 1 in the denominator, and we have in the numerator negative v squared minus v squared minus v. So we just joined the two terms, and we can still simplify this. That's x dv over dx is equals to negative 2v squared minus v all over v plus 1. Now putting all of the v's on the same side and all of the x on the same side, we get v plus 1 all over let's just leave behind the negative value or the negative sign of our numerator in the right side. So that's 2v squared plus v, sorry, we have dv is equals to negative dx all over x. There. So next we're going to integrate both sides to remove our differentials. Now we can try and solve the left side using u substitution. Let's say u is equals to 2v squared plus v, and the du for that is 4v plus 1. Now we cannot do this because if we multiply a value to make the v into 4v, we cannot the remaining plus 1 will also turn into plus 4. So we can employ the fractional decomposition to make our integration much easier. So we can first we need to factor out the denominator. That's v plus 1 times v times the quantity of 2v plus 1 dv is equals to the negative integral of dx over x. So we're here in the right side. Let us solve the partial decomposition, the fractional decomposition. So we have v plus 1 over v times the quantity of 2v plus 1 is equals to a over v plus b over 2v. Oh, sorry. That's 2v plus 1, and that's 2v plus 1. So you guys know already how to solve this. Multiply both sides by the denominator of the left side. That's v times 2v plus 1, so that we can remove all the denominators. Next, we have v plus 1 is equals to 2v plus 1 times a plus vb. So to get our value for a and b, let us set constant values for our v. So let v is equals to 0. So we have 0 plus 1 is equals to 2 times 0 plus 1 a plus 0 times b. Now we have 1 is equals to 2a plus 0. Therefore our a, this is just since 2 times 0, that's 0, so we only left with 1. So that's 1 is equals to 1 times a plus 0. Therefore our a is equals to 1. Next, we can assign another value for v. Let's say v is equals to 1. So now that's 1 plus 1 is equals to 2 times 1 plus 1. Then we already know our value for a, that's 1. Plus 1 times b. Therefore that's 2 is equals to 3 plus b. Therefore our b is equals to negative 1. Therefore v plus 1 over v times the value of 2v plus 1 is equals to 1 over v minus 1 over 2v plus 1. So let's bring that back to our main equation. That's the integral of 1 over v minus 1 over 2v plus 1 dv is equals to the negative integral of dx over x. So I trust that you guys already know how to integrate this. We have ln v minus ln 2v plus 1. So that equals to negative ln of x plus c. Next, the left side, this can be rewritten as ln v over 2v plus 1 is equals to ln x raised to the power of negative 1 plus c. Now we use the values of the left and right side as the exponent for the e. to remove our ln. So we have v over 2v plus 1 is equals to if you can remember, this can be rewritten as e to the raised to the power of ln x raised to the power of negative 1 times e to the power of c, which is v over 2v plus 1 is equals to simply c, because e to the c is also still constant. Therefore, we have v over 2v plus 1 is equals to c x raised to the power of negative 1. So we can erase here our fractional decomposition to make space. So let us substitute back our v to y over x. So that's y over x all over 2 times y over x plus 1 is equals to c over x. Now transfer the x to the left side. That is y all over 2y over x plus 1 is equals to c. Now we have our parameter, which is x equals to 2 and then y is equals to 1. So let us input those values to get the value of c. That's 1 over 2 times 1 all over 2 plus 1 is equals to c. And calculating that is equals to 1 all over 2 equals to c. Therefore, our y all over 2y over x plus 1 is equals to 1/2. So we can simplify this further. This is 2y is equals to 2y over x plus 1, or 2y minus 2y over x minus 1 is equals to 0. And that is our final answer. So I hope you guys were able to follow that. Next, for our number 2, we have dy over dx is equals to x minus y over x plus y, where we have a parameter x is equals to 1 and y is equals to 2. So solving this, again, reminder that in solving homogeneous differential equations, also to verify if it's a homogeneous differential equation, all of the x and y's must be in the same degree. If you see that one has a second degree, or one is x squared and then the y only has a first degree, then that is not a homogeneous differential equation. So remember, we have our v that's equals to y over x, and our y is equals to vx, and our dy over dx is equals to v plus x dv over dx. So we can directly plug in our values. That's v plus x dv over dx is equals to x minus vx over x plus vx. We can factor out the x and the right side. That's v plus x dv over dx is equals to x times the quantity of 1 minus v all over x times the quantity of 1 plus v. We can cancel that out because that equates to 1, and we can move the v in the left side to the right. So that's we have left is x dv over dx is equals to 1 over 1 minus v over 1 plus v minus v, and that is x dv over dx is equals to 1 plus v. In the denominator, we have 1 minus v minus v minus v squared. Simplifying that, we have x dv over dx is equals to negative v squared minus 2v plus 1 over 1 plus v. Now, putting all of the v's in the left side and all the x in the right side, we have 1 plus v over, again, we're going to leave the negative sign in the right side to simplify the integration. We have v squared plus 2v minus 1 is equals to negative dx all over x. Now, we can check if we can, okay, we're going to integrate both sides, and we need to check if we can substitute the left side. So let's say u is our v squared plus 2v minus 1, and our du is 2v plus 2. So yes, we can multiply both sides by 2 and we can employ u substitution. So multiplying both sides by 2, 1 plus v squared plus 2v minus 1 dv is equals to 2 times negative dx over x. So that is integral of 2 plus 2v over v squared plus 2v minus 1 dv is equals to negative 2 dx over x. So integrating that, we get ln of v squared plus 2v minus 1 is equals to the negative 2 ln of x plus c. And using both sides as the exponent for e, or the natural logarithm, to remove our ln, we have v squared plus 2v minus 1 is equals to, that is equivalent to c times x raised to the power of negative 2. So I'm just shortcutting this, but I hope you guys understood how that came to be. So now we can substitute back our values for our v. So our v is, that's y over x squared plus 2 times y over x minus 1 is equals to c over x squared. Now multiplying the x squared to the left side, we have left is y squared plus 2yx minus 1 is equals to c. Now we have our condition where x is equals to 1 and y is equals to 2. So we need to plug those values in so that we can get the value for c. So that's 2 squared plus 2 times 2 times 1 minus 1 equals to c. And that is 4 plus 4 minus 1 is equals to c. And that is 7 is equals to c. Therefore, our final equation is y squared plus 2yx minus 1 is equals to 7, and that can be simplified to y squared plus 2yx minus 8 is equals to 0. And that is our final answer.